Good afternoon. All right, lively bunch. I drew the food coma slot, so I will do my best to keep you all engaged. So I'm also sort of the bridge from this morning's sessions to this afternoon's technical breakout sessions. And so hopefully one of the things I can accomplish is to set up and provide context for a lot of these breakout sessions and what we're going to talk about and what we're going to deep dive in those sessions. All right, so I basically have two things I want to talk about under the guise of security transformation. And what I mean by security transformation is really, first, how security needs to transform to become an enabler. Okay? So if you think about this, we all hear about everything moving to the cloud. We hear about users moving mobile, basically being able to work from anywhere they want to on any device they want to. I understand that doesn't always happen with every user, but these are general trends that happen. And the other trend is moving more toward an analytics-driven model, where, of course, you're collecting a lot of data, but you have to secure the data. And so if we were to approach these kind of digital transformation trends with traditional security approaches, you're not going to be an enabler. And so the first part of security transformation is how we make security an enabler. The second is we just have to get better at security. That may seem like a simple statement, but the reality is security is not where it needs to be. Adversaries are moving faster than defenders are, and we have to figure out how to reverse that trend. Fair? So I'm going to intertwine these two topics throughout my presentation this afternoon. Now, to get started, I try to simplify things before I make them complicated. And for any of you who've seen this particular slide before, it's not a new slide, and that's actually a good thing. I don't think it's good when strategy constantly changes, because it means it wasn't really a strategy in the first place. This came about in thinking through a very simple question, which was, how would we prevent successful cyber attacks? We can't prevent attacks from happening, but the goal is, can we prevent them from being successful? And if I simplify it down, I believe that if you could do these four things really well, like really, really well, I think we'd be in a good position to be able to prevent successful cyber attacks. You would have to start with visibility, because you can't secure what you don't see. You would have to exert a level of control based on that visibility in order to reduce the attack surface. You would then ideally prevent everything that we collectively know is bad. And what I mean by that is not just what Palo Alto Networks knows is bad, not just what you know is bad, but ideally based on what everybody knows is bad. So we'll talk about how we do that later. And then if you could do that, then the last thing to do would be able to detect and ideally prevent attacks you've never seen before. Sounds relatively simple. That's the point. It gets more complicated, though, when you start to think about what you would have to do. And this is not a complete list. This is a sample list of the things that you would have to do in order to accomplish that overall framework. You would have to understand all applications. You have to understand all users and devices and encrypted traffic. And you'd have to apply this to all locations, including SaaS and cloud and mobile. Just to get visibility is actually pretty hard, right? And then you have to think about what kind of controls you would exert over that. And then you have to think about all the different things you have to prevent that you already know is bad. And you have to, there's a lot of work required to do this. That's OK. There's ways to approach this. Now, there's a few things, because we've been thinking about this for several years now. And there's a few overarching principles that we've developed in how we think about this. First is, these capabilities that you see here are way better when they're integrated. Not consolidated, but integrated, where they actually make each other smarter when they're used together. Okay? I'll come back to that later. The other principles we learned from this are more and more of security is going to be analytics-driven. If you prefer a buzzword, we can call it AI or machine learning. I prefer analytics as a more general term, because there's lots of different analytics that is very valuable that's not AI. we have to get much better at automation. We need to find a way to take humans out of as much of the manual work as possible. It doesn't mean that people go away. It just means that people hopefully spend their time on things that only people can do, and machines spend their time on things that machines are capable of doing. And we believe that this increasingly requires a cloud-delivered sort of SaaS security model. This doesn't mean that on-prem goes away. It doesn't mean that we're stripping the capabilities out of on-prem. But as you'll see later, there are certain things that having essentially unlimited compute and storage are very valuable for, and so we'll chat about that. All right? So we have to package that up. Those are sort of principles and concepts. We have to map that into actual tangible stuff. And I'll use this basically as an agenda, so to speak. But the way that to look at this slide is there's things that happen on the network that require network security. There's things that happen on endpoints that require endpoint security. Those are different things, by the way. There are things that happen in the cloud that require cloud security. But then over time, we believe that more and more of the security intelligence is actually going to come from the cloud. That it'll be constantly learning and then constantly reprogramming. And through this model, security will be enforced where it has to be enforced, but it will benefit from scale, leverage, agility, and things like that that we get out of the cloud. And I'll explain that in more detail later. So to start, I want to talk about cloud security. I'm sure for 4 hours this morning, everyone was talking about cloud. But I'll talk through this more in terms of how we think about securing things in the cloud, because I do think it is important. You are all being asked to move as many workloads to the cloud as possible. That's a big task. It's a difficult task. It's made more difficult by a lot of the constraints that are put on you. But it is still happening. So now, whenever we talk about cloud, one of the things we realize is that cloud has many meanings. It doesn't mean that. It doesn't mean your traditional infrastructure. It means the things that are happening off your traditional infrastructure. Now, most conventionally, it means SaaS and public cloud. But I'm going to use it to also talk about how we can use the cloud to secure remote locations and branch and mobile devices as well. So if we start there, let me give you a perspective on this. So many years ago, the world was simpler. Your users and your applications were on your network. And so how you secured your users and applications was a little bit more straightforward. In general, we built perimeters around your users and devices. Everything on the outside was bad, and everything on the inside was good. Now, the reality of that is that has not existed in a very long time. Yet we still see remnants of those assumptions show up in a lot of places. The reality is that your users are all over the place, and your applications are increasingly all over the place. Now, you still have users on your main infrastructure. You still have applications on your main infrastructure. So you didn't get rid of what you had to do before. All you did is gain additional work of dealing with users and applications that are now all over the world, right? So how do we think about this? Now, I'll give you a really simple diagram to describe one of the challenges with this. The traditional approach to this has been, well, I'm just going to backhaul all my users back to my central infrastructure. That'll secure them. And then from there, I'll allow them to go out to the internet, and that's how I'm going to secure it. But if you look at that picture, if you assume it's drawn to scale and everything else, you look at that and go, that's stupid. I just brought all the traffic back across the ocean so I could send it back across the ocean, which has caused a very unfortunate side effect, which usually doesn't happen too purposefully, but does happen, which is the user just connects to the internet directly. It almost makes sense until you realize that there's no security in that. So what do we do about this? Well, typically in security, the first thing we do is we lose our minds. Because that's always the first response, right? We think, I know. I'll deploy a VPN agent to get the user back to my internal applications. I'll deploy a CASB proxy to secure their traffic to the SaaS applications. I'll deploy a web proxy to secure the traffic out to the internet. That'll make sense. I think that doesn't make sense. I think this is the typical response to security challenges that just doesn't make sense. I think we need to take a different approach. And we as Palo Alto Networks have. And it's called Global Protect. We offer it in 2 different formats. I'm not going to talk through a lot of details on that right now, but I'm happy to take questions later. But the general idea of Global Protect is that we approach this looking at this from the perspective of all traffic and applications, all users and locations, being able to provide consistent security, not differentiated security depending on location, but consistent security anywhere, fully connected, bidirectional. Bidirectional meaning that as long as you're trusted in the connection, you're allowed to not just go out, but you're also allowed to access internal applications, of course, based on policy. That's our philosophy. Now, if you simplify this, think of your users and potentially remote locations even. Instead of having infrastructure even deployed into small locations around the world, you could potentially just connect that location to Global Protect. One connection, all traffic, always on. Those are important aspects. All traffic, always on. Not on part of the time, not on for part of the traffic, but everything. And if you imagine if you could take that one connection with everything and now securely from there connect out to internal applications, SaaS applications, public cloud applications, intranet, now what you can accomplish is internal application access, SaaS app, public cloud, internet, everything can not only be secured, but you have secure connectivity. It's important to combine those 2 things together. And it's all done through a single point. Now, you say a single point, that sounded like the first thing you drew. You're right, that's what it sounds like. But those single points need to be everywhere. So what if the users, and in case branch offices as well, what if they could dynamically find the closest point to them, make a connection there, and then from there provide secure connectivity to all the applications that that user needs to access? That's how Global Protect works. And we offer it both as a subscription that you deploy and manage, as well as a service that we deploy the infrastructure for you to leverage. Both do the same thing, though. So now, user shows up somewhere in the world. First thing, they connect to the closest gateway. They get secure connectivity, everything they need. One of the really cool side effects of this, I shouldn't say side effect, side benefits of this is now, using the same central management tool, you can consistently manage policy and get visibility reporting for Global Protect, so any remote users, for your infrastructure, if you're using our next-gen firewalls, and public cloud from one place. And again, it's not just having a consistent management tool, which helps provide consistent user experience, but it's also having consistent security, which is really important. OK. Now, one of the things that we see driving this shift in how we think about securing users when they're off the network is SaaS. The reason this is important is if users are just accessing internal applications, then you might as well bring them back to your infrastructure. But the more users are trying to get to SaaS applications, then the more you want to think about secure connectivity directly to those applications. And the reality is SaaS is proliferating whether you like it or not. You may not have a single authorized SaaS application, and your users are probably using SaaS because they can. And so we break this into a few different categories. Sanctioned, which is the stuff you actually want them to use. Tolerated, which are the applications you might have to allow some users to access with limited abilities, and a bunch of stuff that you probably just want to say no to. And to approach this, the first thing you have to do is you have to get visibility. You have to understand what the users are actually using. From there, you get to exert control. From exerting control, you get to start to manage risk. You get to start to determine who is allowed to use what applications, how are they allowed to use those applications, and of course, how do you secure those applications? We do that in line with network security. We then understand that for the sanctioned SaaS applications, there are additional capabilities by leveraging the APIs that are built into these applications that we can take advantage of to understand exactly what data is there, how that data is potentially exposed, who has access to it, and we can automatically remediate that, again, through the APIs directly to the application. Okay? So we can combine those different capabilities together to provide a complete SaaS security and SaaS enablement capability. Now, I mentioned before there's lots of versions of cloud. I would be remiss if I didn't at least mention public cloud or gov cloud, obviously very important. So first, philosophy. When we think about cloud and how we provide security solutions for the cloud, the first thing we have to think about is it needs to be developed for the cloud. I'll give you an extreme example. I could sell you a piece of hardware, and you could ship it to AWS and ask them to install it. I don't think they will. I'm quite confident that they won't do that because they don't install your hardware. They run the cloud, and you need to make sure that you have the right form factor to fit within that environment. Now, it goes way beyond form factor. We have to design these solutions to work in the cloud. We have to think about the dynamic nature of the cloud, how automated the cloud is. We have to think about horizontal scalability instead of vertical scalability. There's a lot of things that go into thinking about a cloud-based model. Second is, we have to be designed for speed. Unless you don't care about getting the benefits of the cloud, we have to be designed for speed. We have to be able to move at the same speed as the cloud. And third, it is a multi-cloud / hybrid cloud world. AWS is not going to secure Azure. Neither one of them are going to secure GCP. You need to be able to provide consistent security across the different clouds. So these are the principles of how we think about this. We put these to work when we think about what we do. And what we do is we focus on inline security. So this is all of the same network security capabilities, but packaged in a cloud format, designed to work in the cloud, be automated in the cloud, scale on the cloud, et cetera. We combine that with host security. While the underlying host is the infrastructure's responsibility, they then expose a hypervisor to which you then run an operating system on top of. You need to secure that. Without securing that, you're not going to be able to secure the application running on top of it. The third thing, and potentially the most important then, is the API-based security. The public cloud exposes an amazing set of interfaces that allow us to understand what is running in the cloud, how it is configured, how it is being used, that is really important from a security perspective. And so we've made 2 acquisitions as a company this year in this space specifically because we believe it's that important. Evident earlier this year, and just a couple weeks ago, a company called Redlock. And what we're able to do with these 2 offerings is provide continuous discovery and visibility. So what is running in the cloud? Again, if you don't have visibility, you can't hope to do anything else, right? The second is, with that visibility, can we have complete and continuous compliance? Now, I don't just mean regulatory compliance, I also mean security compliance. From there, we need to make sure that different services, things like storage, are secured effectively. Anyone who hasn't paid any attention in the last year and a half, basically everyone's storage, S3 buckets and things like that have been shown to be opened at some point in time. It's very unfortunate. It's just accidental misconfiguration, misunderstanding how the services work, but this kind of stuff happens all the time, and so we have to focus on some of these key services. And then lastly, we have to constantly monitor the activity to make sure that that even when it's configured correctly, that it's actually being used correctly. And so we're constantly monitoring these services for malicious activity, right? And then across all of this is how do we then automate responses when we see things that are out of whack? And so this is what we're doing from a API-based security in public cloud combined with inline security and host security. All right? So a lot on cloud, but there's a lot of other things that really matter. And we're going to switch to endpoint. So there are certain things that can be done from a security perspective on the endpoint or the host that cannot be done on the network. There's a set of things you can do on the network that cannot really be done on the endpoint, at least not without cratering the endpoint, which defeats the purpose. So the network and the endpoint are very complementary. And they're both very necessary. And so when we approach endpoint security, the thing we need to be thinking about is what can we do uniquely on the endpoint that complements what we can do from a network security perspective. So in thinking through that, we have to deal with malware. Now, we can do a lot of this on the network, but there's certain things we can do on the endpoint that matter. We need to think about fileless attacks. This is something that is fairly unique to the endpoint in terms of being able to see it and do something about it. We need to think about exploits. Now, we can do this on the network through IPS capabilities, but IPSs only prevent things that you already know about. On the endpoint, we can actually prevent exploits we've never seen before. I'll explain that in a second. And we need to think about stolen credentials. Stolen credentials are used in some ungodly percentage of attacks. It's like 80-something%. It's ridiculous. Now, there's a bunch of stuff we can do on the network, but there are certain things we can do on endpoints as well around this. And there's going to be new techniques that come along as well when we get better at preventing against these techniques. Now, our approach is always a prevention-first approach. I'm going to come back to this concept in a little bit and talk about how we expand upon it. But this approach basically says, if we can prevent an attack, we should. There may be cases where we can't prevent it, and we need to detect and be able to respond to it. But if we can prevent it, we believe that that is a very good thing to do. This gets back to how do we have people do things that people need to do as opposed to constantly run around responding to stuff. So we take this approach. We're going to try to prevent malware, ransomware. We're going to try to prevent exploits as best we can, fileless attacks. And ultimately, we want to be able to use the endpoint to be able to detect and ideally prevent, if not prevent, then respond to the more sophisticated attacks as well, attacks we've possibly never seen before. I think if we could do this, that would be very valuable. Now, how do we do it? Let's start with malware. Malware is an interesting beast. As a starting point, the goal would be to prevent all malware that's already known. Now, historically, the way endpoint security works is malware signatures. How many signatures would it take to prevent all known malware? It would be a fairly incredible number, and anyone who tried to profess to tell you what the number was would probably be lying. I don't know what the number is, but I know the number is bigger than I can write signatures and stuff on an endpoint. So we have to think about ways of leveraging a combination of on-prem plus cloud scale in order to be able to do this the best possible way. Second, we need to leverage machine learning to be able to build local analysis modules that can prevent variants of known malware. This also works very well for preventing known malware, by the way, because variants and known are sort of the same thing in the concept of machine learning. We need to use behavior-based models to understand the behavior of families of malware. And we need to have mechanisms for analyzing new files we've never seen before. We do this in a service called Wildfire. I'll talk a little bit more about it later. But basically, this does things like dynamic analysis, static analysis, bare metal analysis, et cetera. And if we did all of that, we would think we'd be pretty good at prevention. But in the process of doing that, we would get better and better at knowing about new malware such that it's a cycle that makes itself better, right? And so this is how we think about preventing malware. And we think about this across traditional families of malware, non-traditional families of malware, et cetera. The second part is on exploit prevention. We took the approach years ago to think about this in the form of exploit techniques. Okay? So what this means is when there's a new Microsoft Super Tuesday announcement and they announce a set of new vulnerabilities, what they're basically saying is they or somebody found a flaw in their code that can be exploited by someone trying to do bad things. So you can exploit that flaw, that vulnerability, in order to run arbitrary code, in order to steal something, in order to do whatever. But you still have to exploit it. So traditionally, the way we deal with that is we write signatures to detect the exploits. If you get really good, you write signatures to try to detect the vulnerability. Exploit techniques are different, though. What we focus on are the ways in which attackers will exploit a vulnerability. And we detect those methods. The reason we do this is there are millions of vulnerabilities, and there are millions of exploits. But there are not very many exploit techniques. And so if we can detect and prevent the techniques, then we actually can get very good at preventing exploits that we've never seen before. Okay? And we have a history of this, dating back to as early as 2013. And what you're seeing are the progression of all the different exploit techniques that we've been able to add, and across the top, across the different operating systems in which these apply. And they apply to the different kinds of techniques that are used. Okay? So I mentioned before this prevention-first approach. But we're self-aware enough to understand that we're not going to prevent everything. Now, maybe you're not used to security vendors acknowledging that, but I'll acknowledge that. We're going to try to prevent as much as we possibly can. I would love for that to be 100%. I even tell our security teams I want 100%. But at the same time, I understand probably will never be 100%. So how do we take a prevention-first approach, but then combine it with detection and response? And ideally, if we do that really well, we can be very good at detection of the stuff we didn't prevent. Ideally, it won't be very many things, which means that it's actually something you can get your arms around, right? And ultimately, if you respond fast enough, you can actually prevent the attack. So what do we want to be able to do with this? We want to be able to use a detection capability to discover and hunt for threats. That's maybe an obvious statement, but ideally be oriented toward things that can't be prevented outright. So again, thinking about how we complement different aspects of the platform. Second, we would try to automate and simplify as much as we possibly could. Make it easier for people to do their jobs. Don't make it like a lock, where there's those rooms that you have to find the clues to get your way out. It's not like, here's one piece of information, see if you can find your way out of the room. No, here's all of the information you need to determine what happened and how to respond to it, and ideally try to make that happen as quickly as possible. And lastly, not just respond, but can we adapt our defenses as well? Can we learn from what we discovered to make an unknown known? Because once it becomes known, then we should be able to prevent it the next time we see it. And if we can use automation, that'll happen really fast. So this is the one piece of my presentation where this is future. This is something we're working on. We're actively working on it. We're making great progress on it. And we call it XDR. Now, what's unique about this is not the three main aspects. I mean, we're going to try to take a unique approach to do it better and all that kind of stuff that you would hopefully expect us to do. But we're going to do that not just across endpoint data, but also network data and cloud data, so that when we're detecting attacks and investigating attacks and providing all the context necessary to respond to attacks, we're going to do that across a very broad set of data, as well as a very deep set of data as well. So this is our view for how we take detection and response up a level. Make it more capable, make it more accurate, make it more useful. All right? One aspect of this that I believe is very important, and this is partly why we're combining these different data sets together, is this notion of activity chains. If I showed you that and said, good or bad, is Outlook good or bad? Outlook's good. Is Chrome good or bad? Good. Are scripts good or bad? You may say, oh, scripts are bad. No, actually, scripts are used in a lot of environments. You can't say scripts are bad. Is a connection to that IP address good or bad? I don't know. Probably fine. It all looks fine. Unless you understand that this user, using Outlook, downloaded a script which ran in Chrome, which initiated that outbound connection, at which point you would go, holy crap, that's not good, right? We have to bring causality into play. We have to understand what action led to the next action, which led to the next action, in order to be able to detect malicious activity, but also to be able to understand and investigate and figure out, is it real? How do I respond to this? What happened? So we have to bring different data sources together. We have to stitch them together to understand how they're all related to each other. All right. I mentioned before this idea of cloud-delivered services. And what I mean by this is there's a lot of different enforcement points, but how do we leverage the scale of the cloud to do a better job? I believe this is necessary for these three reasons. Scalability. I think it's already past a point where ability to truly scale at the level it needs to be scaled in fixed form factors. The number of bad things that we know about doesn't fit. And if we extend what we know about to what everybody knows about, it's definitely not going to fit. We have a scalability need. Second, we have a leverage need. Adversaries work together. They share stuff. They sell code to each other. You can buy ransomware as a service if you want to. We, as defenders, need to get more leverage from each other. We need to be able to share threat intelligence if at all possible. I realize in this room, sometimes what that means is you get the benefit of others and you can't necessarily benefit others. I get it. But in general, as a general approach, we need to be sharing threat intelligence collectively if we want to get better and better at knowing about all the bad stuff out there. And lastly is agility. How fast from when I give you a new software update can you have it installed and running? I'm guessing it's not as fast as I can update my infrastructure and just have it be available to you. Agility, when we're dealing with adversaries and attackers, is really important. I believe we need these three attributes working in our favor, not working against us. So let me give you an example of this. We have a service called Wildfire. We released it about 7 years ago. When we released it, it had basically one capability. We could take executable files and do dynamic analysis. 7 years later, it looks like this. Just about everything we have APIs, which means it can send to just about anything else, can submit just about any file type you could want. When we receive it, we do static analysis, dynamic analysis, bare metal analysis, dynamic unpacking, network traffic profiling using machine learning. I probably missed something. Every 5 minutes, we take what we learn and we make it known to every device we have and every endpoint we have. We just added credential phishing, URL extraction from documents. We're constantly adding new things to this. Now, let me give you a sense on the agility side. So I mentioned 3 things on the previous slide as being relatively new, and in this case, new within the last 12 to 18 months. Network traffic profiling. So this is machine learning of the network traffic we see. Custom hypervisor. Everyone says they have a custom hypervisor. Ours is 100% built from the ground up custom. I mentioned dynamic unpacking. This is a mechanism to deal with packing that's often used to try to obfuscate malware. Serodip. This is a piece of malware that's interesting because it uses Twitter for its command and control. The way we detected this was being able to look at the network traffic profiling, the machine learning models that we apply to the network traffic when we run samples. Unique capability for identifying unique malware family. Gravity Rat. It checks the temperature setting on the host to figure out whether it's running on a real host environment or a virtual host. Because virtual hosts don't have temperature settings. We figured this out because we have the custom hypervisor combined with bare metal analysis. Kill Disk Wiper. It unpacks, or it is packed using a custom packer, which bypasses any form of static analysis and machine learning, which are becoming very important components to how you detect attacks. And so the dynamic unpacking allows us to actually dynamically unpack and actually apply static analysis and machine learning to analysis. So these are 3 examples of 3 innovations that if you're using Wildfire, you just get. That is the value of an agile service. All right. Now, there's another benefit that Wildfire provides, which is it's analyzing about 20 million unique files every day from around the world, and tens of millions of URLs, unique URLs. That has now produced over 7 billion files that have been analyzed. Billions of files. That's generated over 5 trillion artifacts of information that we store. And we correlate every artifact with every other artifact. You may say that sounds crazy. The reason we do that, though, is because it allows us to track similarities. More importantly, it allows us to identify dissimilarities. It allows us to identify when something is being seen for the very first time because we can compare it to 5 trillion other events and say, never seen this before. That might be important. In fact, 86% of all malware that we see is now attributed to either a specific adversary or a specific campaign. And that number keeps going up. It was about 60-something% a year ago. This becomes important because the inverse of that is the unknown. That's a very interesting data set. Now, perhaps even more importantly to this audience is our FedRAMP status. This morning we announced that Wildfire has now achieved FedRAMP ready status, a huge milestone because basically it means that all the hard work is done and now we're waiting for the rest of the process to take place. Not that the rest of the process is necessarily fast, but at least the hard work is done. We are working toward, after that, we'll be working toward the DoD IL4 level add-on, which will be very important to some of you as well. You can see the rest of this. Very pleased with the progress we made. As many of you know, the FedRAMP process is a very hard process, rigorous process, but it's one that obviously is very important to us because we want to make sure that these kind of capabilities that I'm describing can be made available to all of you. All right. So one of the things about cloud-based services is the idea of making it a lot easier to adopt new capabilities. So if you have our next-gen firewall and you want to adopt Wildfire, it's a configuration setting. That's how easy it is. You don't have to deploy all new infrastructure. We want to be able to do the same thing, but open it up to an ecosystem of innovators. We want to make this easy for you to consume new applications in the future. Okay? So if we think about this, what we're really trying to solve is the traditional consumption model. The consumption model that says every time something new and interesting comes along in security, you have to go do this. You have to figure out who's going to be the expert. You have to go through a planning process. You issue an RFI to figure out what other people know about it. You then, once you've gathered enough information, you issue an RFP because now you know enough to be able to say, all right, who's the best at this? And you narrow it down to 3 vendors, and you test those 3 vendors. You try to pick the best one. Then you go through the procurement process, which I hear is really easy. And once you do all of that, hopefully you get to buy one. Once you buy it, you get to deploy it. Once you deploy it, you get to depreciate it. So something that was a really urgent, important security need just took you 8 years. That can't be the model, right? So what if we could collect a bunch of data from the network, a bunch of data from endpoints, a bunch of data from the cloud. We could combine that data with threat intelligence from the community, threat intelligence that we have, third-party threat intel, researcher-sourced information. What if we could combine all of that information in one place? And what if by doing that, we could build the next security application like we did Wildfire as a SaaS service that you get to consume? And that whole consumption model could be turned on its head. We've done that. We have done exactly that. And the first application we delivered in this new model is behavioral analytics. This is how you would normally do behavioral analytics. If you wanted it, you said it's important, you would deploy probes across your entire network infrastructure to collect the data you need to be able to analyze the data in order to provide the function, which is behavioral analytics. which is designed to look for anomalous activity from users, either detecting an insider threat or malicious activity on someone's computer. Or, in the new model, you would simply take your next-gen firewalls and collect the network data that is necessary as opposed to deploying new probes. You collect that to a central location we call the application framework, and you'd run machine learning, behavioral analysis against that. We did that, and we released that as an application that can simply be consumed. And then as a cloud-based application, every month we are constantly adding new capabilities to this magnifier service. All the benefits of centralized, rapid innovation, et cetera. We even got to the point where we have over 30 third-party apps that have built prototype applications that run the same model. We have the first 7 or 8 that have become production-ready applications. Now, this is the early innings. This is the start of a long process, but this is the start of a long process that is going to change how we all think about delivering and consuming new security capabilities. All right, last piece. Something that is very near and dear to my heart is this idea of getting the most out of the platform, the most out of the things I talked about. It's very near and dear to my heart because my team spends a ton of time trying to build the next security innovation, trying to build the next best product, trying to build the next best operational capability, trying to build the best next whatever. And nothing pains me more than to see the product deployed and only 10% of it actually turned on. And so we started to think and spend a lot of time over the last few years of how we can help you get the most out of what we do. All right? Now, let me start by providing a little background on some of the network security stuff that we're doing. This will give you an example of how we think about what we do to make your jobs better, easier, et cetera. Everything's increasing. Encryption is increasing. Attacks are increasing. Throughput's increasing. Everything's getting more. Over the last 7, 8 months, we've released a number of really important capabilities. To make it easier to adopt our security capabilities, to make it easier to get granular visibility and control over SaaS applications, to make it easier to decrypt SSL traffic, and to make sure it's easy to do all of these things at higher and higher scale. We've basically revved the entire hardware product line over the last 2 years. 5 times faster in throughput, 7 times faster in decryption throughput, huge increases in session capacity, I/O capacity. All of this is designed around this idea that everything is increasing. That is not useful if you get stuck in LA traffic in a race car. So, a few things we're doing. One, we're making it easier to do what we call a security lifecycle review. This is a tool that we've had in the past for many years. It's something we often do during evaluations. We're now making it available for production environments. It's designed to basically take data from the products and say, here's what's actually happening in a sort of almost a business format, something that's easily consumable by people that aren't just technical. We've had a migration tool to migrate config from some of our competitors to us. Today, I'd say 25% of that tool is migration. 75% of it is actually taking our own configs and making them better. Rule consolidation, leveraging app ID, user ID, implementing best practice adoption. Speaking of best practices, we have a whole best practice assessment tool that's designed to make it easy to understand where you are relative to what we believe the best practices are. So the SLR, our teams typically run this. We actually turn this to an application on the application framework, which means that if you're using the logging service in the application framework at some point in the future, you'll be able to simply consume this as an application, use it whenever you want to. Expedition, as I mentioned, a lot of the innovation of this is now going well beyond migration. We're trying to make it as easy as possible to get to a rule base that actually makes sense, that you actually understand what it does. And the best practice assessment, we first had to decide what we believe the best practices are for security of our products. But then we turned that into a tool that can analyze configs and determine where you are relative to those best practices. I'll give you just a quick snapshot of this. So this is showing basically a high-level output, which is kind of where you start, overall adoption of some of the key capabilities. It can go into detail and say, I want to see that adoption across every firewall I have or groups of firewalls. So you can actually do this against Panorama if you have a large deployment. It can tell you how you're doing over time. Hopefully, you're getting better. Importantly, it'll also tell you what you need to do to fix it. This is a really simple example. What it's basically showing is this customer had adopted Wildfire, but they had set the action to alert. This tool detects that and says, yeah, you're using Wildfire, which is a good start, but you should turn that into prevention. Some of the fixes aren't quite that easy. That's an easy fix. And like I said, over time, hopefully what you see is more green than red. We can help you run this tool locally. And over time, we're looking at making this a continuous tool that would constantly be running against your configs. So at any point in time, you'll know where you are relative to these best practices. All right? Now, one of the tools, call it a tool, experiences that we've created that we've seen as being extremely useful, it's called Cyber Range. And this is just a quick plug for it because we've seen just tremendous interest and response from this community in being able to leverage it. It's basically an environment where you actually get to test out your skills and test out the platform and see how it works in a cybersecurity environment. Very cool, real-life kind of scenarios that you or your teams get to experience. So, if we do all this, we hope, we believe, that we will get a lot better at preventing successful attacks. We believe it'll make it possible to focus on what really matters. And what I mean by this is people focusing on what really matters, automation taking care of everything else, and making it a lot easier to consume new innovations. We have to get past the traditional approach to security where everything is a chore, where everything is a multi-year process to be able to respond to something that's urgent. All right. The last thing I will leave you with, I promise, the last thing. We will be here again next year, October 10th and 11th. We're still working out, I think, where here is, somewhere here. Details coming, but I really appreciate your time and attention. I know it's difficult to come back from lunch, but I appreciate everyone being here. Hopefully this was helpful. Out these doors, we have some really, really, really great breakout sessions for you. Hopefully you'll get a lot out of those as well. And with that, thank you very much.